Okay, hey everybody. I'm gonna put a little time into making a video on section 9.1 homework. So I think we just go ahead and look at the first question. That'll probably be sufficient. And this is really similar to the one that we did in class. So you've got the numbers are different here, but it says we've got registered numbers of registered automatic weapons and murder rates. That's murders per 100,000 people in 10 randomly selected American cities. And it says we should give the means and the sample standard deviations for X and Y below. So on this, we just want to go into your calculator, and in the data menu, we can just go ahead and start entering all the values. So for the X's, I'll do all the X's first. So 3.1, 3.2, 2.5, 6.7, okay, 2.5, 6.2, 5.9, 6.9, 4.8, 3.5. Okay, so that's 10 data points, and then the next will be the y coordinates. So 3.5 for the first one, 4.9, 4.3, 6.1, 4.7, 7.0, 6.1, 6.7, 5.5, and 4.8. Okay, fingers crossed. Oops, that's a mistake. 4.8. And then I would just kind of go through this, make sure everything's good. Just a little nervous because I make so many mistakes. Okay, the first four are fine. Uh-oh. Those look good. Okay, everything looks good. So I'll go ahead and clear that, and then just get our two variable statistics. So you just want to press second, and then data, and now we just make sure to pick two variable statistics here, and you get tons of info when you do this. Among the let's see, there we go. So among the values you get are the mean and the sample standard deviation and so on. So of course we're going to need all that. So let's go ahead and start putting in some of these values. So, and it says we want how many places? One place for X bar. So I'm just going to do 4.5. Okay, but for Y, and for Y bar, let me go down a little here and see if I can spot what Y bar is. There we go, 5.36, but we have to do one place, so 5.4. Okay, standard deviation of X is up there, and it says three places, 1.769, I'm going to go 770. Okay, and then the standard deviation of Y is right there. Again, three places, 1.113. Like that. And then, right? Yeah. And then we want to go way down to find R in here. So somewhere, A, B, and R. Okay, R is 0.8978. It wants three figures. So we better do 898. Put that in, looks good. And those hopefully will be all good. I'll check my answer. And yes, they are all great. All right, now then from here, we're going to have to compute the slope and the y-intercept for the line of best fit. Okay, so I think what I have to do is I'm going to bring up my Notability real quick. Here's Notability, and I'm going to just open up like that. Okay, so now we see the formula for the slope, so I'll just go ahead and do it here. Slope is r times sy over sx. Okay, so the r value was 0.898 times sy, which we're going to do 1.113, and then over sx 1.770. Okay, so we'll do that real quick. I'm just going to use a real calculator so I can leave that on the screen. So it's simple enough to do. Okay, 0.898 times 1.113 divided by 1.770. So I get a point, and it wants how many places? 3 places for the slope. So 0.565 is what I'll go with. And I think I'll just make sure this is right. Okay, check that. That's good. Now, again, the formula for the y-intercept is here. Okay, so this will be y bar minus the slope times x bar. So the y bar, of course, is 5.4 minus the slope 0.565 times x bar, which was 4.5. Okay, and again, I'll just do this on a real calculator. Okay, and I get 2.8575, and it wants 1 place. So I'm going to round that to a 2.9, like that. Okay, so let me do this real quick. Like that, and as I said before, I'm checking it now. Looks good. Now the line of best fit is y hat equals it's the y-intercept plus the slope times x. So here, the y-intercept we rounded to 2.9 plus the slope, that would be 0.565 times x. And so now I gotta put that in here. There's a little bit of a kind of a template for typing stuff that my keyboard's covering up, so I'm just gonna use a regular keyboard. So let's see here. Y hat is 2.9 plus 0.565 times x. There should be an x in this. Okay? And so remember, the equations of lines have 2 variables, an x and a y, just like I've done. And so you can see everything looks great here. It's changed the order on the multiplication. So 0.565 times x plus 2.9 is what it says here. That's fine. Okay, so now to interpret the slope, just to help you with this is something we didn't have a chance to talk about in class. So I'm just going to put it here. Slope equals increase in y when x increases by 1 okay, so the x is the number of automatic weapons, I think, and y is the murder rate. So if the number of automatic weapons goes up by 1, then we expect the murder rate to go up by whatever the slope is. And in this case, it's 0.565. So, all right, so we see it here on the first option. When the number of registered automatic weapons in a city increases by 1, the murder rate will increase by 0.565 per 100,000 people. That's exactly what I said. Okay, now the y-intercept is equal to the y value when x is 0. Okay, so in the context of this problem, x is the number of automatic weapons. So if there's no registered automatic weapons in a city, then x would be 0. And the y-intercept would be the y that goes along with that. That would be the murder rate. So the y-intercept would be the murder rate for a city that has 0 automatic weapons. So if you look at the choices here, it says the predicted murder rate, the second choice, predicted murder rate corresponding to a city with 0 automatic weapons is 2.9 murders per 100,000 people. That's exactly what I had said. Okay, so that's good. Now it says it wants us to estimate the value of y hat corresponding to x equals 2.5. Okay, so here you would just copy the formula down for y hat, but x is 2.5. Okay, so the y hat formula up above, I'm just referring to this one. I'll put in a 2.5 for x here. Okay, so this will be 2.9, oops, plus 0.565 times x, which we're putting in a 2.5. Okay, so just on a real calculator, I'm going to get, double checking my numbers, 2.9 plus 0.565 times 2.5. I get 4.3125, and it says to one place. So I'm just going to go with approximately 4.3, and let me put that in for my answer here. 4.3 should be okay. And I don't see a place to check here, but somewhere I can check my part answer. And let me just verify. 4.3 is good. Okay, so then for this part of the problem, we want to do a scatter plot. And so that's going to involve putting all these points, which I've now labeled as A through J. I'm going to put them into correct position on the scatter plot down here. They're in a bit of a pile right now, and they need to be moved. So point A, if you look at the scatter plot, look at the table here, it should be at 3.1, 3.5, and I'm just going to grab it here. And then if you look right up here, you can see the coordinates. I need to get it to 3.1, 3.5. So I usually start by moving it with my my mouse or my stylus. But I'm using an iPad right now, so using your finger kind of helps once you grab the point. Anyway, that's 3.1, 3.5. If you go up, the next point is 3.2, 4.9, so I'll grab that. Just get it in the ballpark. Again, you can see the second point now is this. 3.2, 4.9, something like that. Let me just tweak it a little with my finger, just a little fine tune. And there it is. Okay, 3.2, 4.9. Okay, the third point is C, should be 2.5, 4.3. And here somewhere, it's a little off, so let me get it just right. 2.5, 4.3. Okay, now the fourth point is D, it's 6.7, 6.1. This is way over here. Okay, again, fine-tuning it to 6 point, don't know why it does that, 6.7, 6.1, right there. Double check that's correct. 6.7, 6.1, yes. Next one should be E, which is 2.5, 4.7. Okay, so just kind of grabbing it. 2.5, 4.7 is going to be up here somewhere. Just off a little bit. Oh, almost had it. Really hard to do with the stylus. That's it right there. Okay, next one is F. So F should be at 6.27.0. So that's not too close to the others. It'd be easy enough. 6.2. 7.0. Yeah, it's easiest just to get in the ballpark and then use my finger. Like that. Let's double check that. 6.2, 7.0 is correct. Now I'm on G. So for G, it's 5.9, 6.1. Up in here. Okay, I'll fine tune it now. 5.9, 6.1. Like that. All right. Now we're gonna do the next point which is H. We can see down there. So if I look at H, it's 6.9, 6.7. Okay, so 6.9, 6.7 is gonna be up here somewhere. Right there. Now I is at 4.8, 5.5. Somewhere in here. Got it. And then J, the last one, is 3.5, 4.8. I guess there. No, it's just a little low. A little tricky. All right, yeah, got it. 3.5, 4.8. So that's my scatter plot. Looking great. Again, I think I'll go ahead and check my answer. Hopefully it's gonna just like everything. Yeah, it's perfect. Okay, so then on it's it. Oh, and I have to graph the line of best fit also. So the y-intercept is labeled I, so you can see I'm going to grab this green point here. That's the y-intercept, and I need to put it whatever the y-intercept was. And if you look up, the y-intercept was 2.9. So I'm going to grab that. Remember, it's got to be on the y-axis. I'm just going to try and set that at 2.9. And up here, if you look right up here, you can see the y-intercept moving as I move this around. So again, 2.9. Roughly there. I think that's a little low. That's 2.8. So you got to come up a bit. Okay, so the x coordinate should be 0 there, and the y coordinate is 2.9. Now M is the mean point, so it's easiest probably if we look at the mean point up here. So for the mean, x bar, you can see right at the top here, is 4.5 and y bar is 5.4. That point is always on the line. I'll go ahead and make a note of that. So the mean point that's x bar, y bar. Okay, here again, x bar, oops, is 4.5, and y bar is 5.4. That's always on the line. Okay, so I'm going to just move that mean point into position as I finish this problem up. Again, it's 4.5, 5.4. So, and you can see its position up here at the top. Again, let me just kind of highlight it. It's up here. So 4.5, 5.4, I think might be, not that, right there maybe? You see it up above here, it's 4.5, 5.4, the mean point, and as it's finally into position, you can see this is definitely a line that goes right through the middle of the data points. Okay, so that looks great. And then I'll go ahead and describe my relationship here. This is a linear relationship because the points do kind of follow a line. It's not on the line, but they're kind of around a line. So we call that linear. Is the relationship positive or negative? Well, positive relationships go uphill. Negative ones go downhill as you go to the right. Well, this one is going uphill as you move right. So that's just kind of the definition of a positive relationship here. So we'll call it positive. Okay. And then they're going to ask us about the strength of the relationship. Is it weak, moderate, or strong? And I don't know. So yeah, I've got my R value here of 0.898. And what we said was if R is between 0.8 and 1, that's a strong positive relationship. Okay, and you want to look in your notes at 9.1 to see the other categories here. Okay, so we'll just call this strong. Okay, and now they want R squared. Okay, so I think I'll just take my R value, and I'm a little nervous about this, but I'm going to go ahead and my R value again here is 0.898. You can see it right here and there, 0.898. Okay, and so that comes out to about 0.806. And I'm going to check and see if that works okay. I'm squaring a value that I already rounded, so that's what I'm nervous about. 0.806, we'll check that. Yeah, it's okay. So the machine was looking for a 0.806 there, so we're all good. And then the definition, then R squared tells you how much variation that you see in Y that's explained by X. So it's 80.6% of the variation in the murder rate that's explained by the number of automatic weapons. So here is the answer for that. Okay, it's the variation in Y that's explained by X, and R squared is the percentage of that. Okay, so we can keep going now. I think it's done. Yeah, 9 out of 9, we're good to go. A little bit of work, but there it is. And good luck, everybody.